This is Dr. D. Govardhan, Professor and Dean, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are discussing the topic of Mohr circles for the stresses which are acting on the body in two mutual perpendicular directions and in mechanics of solids. The Mohr circle for these stresses on oblique section of a body subjected to direct stresses in two mutual perpendicular directions. Here consider a body of uniform cross-sectional area having unit thickness as shown in figure. It is subjected to two direct stresses which are mutually perpendicular to each other. That means one is along the x-axis, one more is along the y-axis now. So the stresses which are acting on the object along the x-axis is represented as sigma x. Similarly, along the y-axis is equal to sigma y as shown in the figure now. Now let us consider an oblique section CB which is making an angle of theta measured in clockwise directions as shown in the figure now. The given data in this problem is sigma x. Sigma s is representing the direct stresses which are acting on the plane AC. Similarly, sigma y is representing the tensile stresses acting along the y directions now. Generally, it is treated as the minor axis. Along the x-axis, it is treated as the major axis now. Theta is the angle made by the oblique plane with respect to the x-axis measured in clockwise directions. Now, first of all, we have to consider the equilibrium of the wedge. For this one, just draw the circle by using certain suitable scale now. Here in the given problem, sigma x and sigma y representing the stresses, both are in tensile in nature. Hence, they are taken as a positive. That is, they are moving from left to toward the right side while representing in graphical method now. Now, according to the Mohr circle, first of all, draw the horizontal lines. Here, x and x now, x and x of convenient length now. Just mark point O on it. Mark a point O on it. And represent a length OK, which is equal to the length of sigma x. Here, which is OK, it is equal to the length of the sigma y. Similarly, OJ is representing the length of the sigma x as shown in figure now. That is, first of all, is to draw the horizontal lines. It is represented as the xx and mark a point O on it. And by using the suitable scale, represent OJ as well as OK. That is, starting point is O, just moving toward the right hand side, OJ and OK, such that they are representing sigma x and sigma y according to some suitable scale now. The point here now, J represents the stresses on a plane AC, and the point K is representing the stresses on BC according to the wedge section now, which what we consider now. Now, JK is representing the, here now, we are taking OJ is equal to sigma x. Similarly, OK is representing sigma y. So, OK minus OJ is representing the sigma x minus sigma y. That nothing but here KJ is representing the difference of sigma x and sigma y. Just take it as a diameter now. While drawing the circle, take the difference of the dimensions of the two direct stresses, that is sigma x and sigma y, the difference values we are taking as diameter and representing a point C on it such that it is the midpoint of KC now. Now take C as center, radius is equal to CK or CJ, draw a circle now. This circle is known as a Mohr circle. Now through C, draw line CP, here CP, making an angle of 2 theta with the CK, that is the x-axis, measured in clockwise directions such that it has to meet the circle at a point P now. The point P is representing the stresses on the section AP now. Now through P, draw a line to meet the O point, that is starting point, that is O and P. At the same time, draw perpendicular from P to meet the lines OJ at a point Q as shown in the figure now. That is from P, we have to draw the two lines now. One is to join the initial position O, that is OP. The second one is nothing but just PQ now. Now OQ, OQ and QP and OP, these three forces we are considering. One is the OQ. OQ is representing the normal stresses acting on oblique plane according to this circle, and PQ is representing the shear stress, and OP is representing the resultant of shear stress as well as the normal stresses which are acting on oblique plane according to the some suitable scale now. The angle POC, this angle is representing the angle of obliquity. Just check whether it is the correct or not now. The proof is from the geometry of the Mohr circle of stresses now. Here KC is representing the radius of the circle. Here which is equal to half of the difference of the stresses sigma x and sigma y now. That is here Kc is equal to Cj also equal to Cp, which is equal to half of the values of the difference of stresses, that is sigma x minus sigma phi by 2 now. The second one is here OC. OC is equal to, we can take it as OK plus Kc. OK is equal to sigma y plus Kc is equal to, we can take it as sigma x minus sigma y by 2. From this relation we got which is equal to sigma x plus sigma y by 2 now. OC equal to. So normal stress is equal to normal stress, which is equal to OQ, it can be written as now OC minus OQ now. OC minus, here we required OQ values required now. So OK minus QC. This is known as here now normal stress now. From these relations now, already we determined here now OC is equal to, we got the values now, which is equal to sigma x plus sigma by 2 now. We already got which is equal to sigma x plus sigma y by 2 minus, here we required CQ values required now. The CQ values is equal to, we can take it as CP into cos 2 theta now. CP into cos 2 theta now. CP is nothing but representing the radius of the circle, which is equal to the half of the difference of direct stresses now. That is sigma x minus sigma by 2 into cos 2 theta. This is nothing but the same results already we got by using analytical method now. Similarly, the shear stress is equal to, we can take it as PQ. The PQ is equal to Cp into sin 2 theta, or which is equal to Cp is equal to nothing but representing the radius of the circle, which is equal to sigma x minus sigma y by 2 into sin 2 theta now. So we got the same results, just what we achieved earlier by using analytical method now. The maximum shear stress will be equal to the radius of the Mohr circle. That means which is equal to sigma x minus sigma by 2 now. It will happen when 2 theta is equal to 90 degrees or 270 degrees, or theta is equal to 45 degrees or 135 degrees now. However, when theta is equal to 45 degrees, then the shear stress is equal to the sigma x minus sigma y by 2. And when theta is equal to 135, the shear stress is equal to minus of sigma x minus sigma y by 2 or sigma y minus sigma x by 2. This is nothing but representing in opposite directions. Minus sign is representing. So the results what we received are obtained from the Mohr circle are similar to the analytical method. But by comparing the Mohr circle, it is very easy when comparing with the analytical method now. Okay, just one more problem, just based on Mohr circle. A point in a strained material is subjected to two mutual perpendicular tensile stresses of 200 megapascal and 100 megapascal. Determine the intensities of normal, shear, and resultant stresses on a plane inclined at 30 degrees with the minor tensile stresses now. Here the given data in the problem is the tensile stress along the x direction. So it is also known as major axis, which is equal to 150 megapascal. Similar tensile stress along the y direction is equal to 100 megapascal. Is given. The angle made by the oblique plane with respect to the positive x-axis direction is equal to 30 degrees. That is nothing but measured in clockwise directions. This is the given data. The solution is the normal stress across the section AB sigma n is equal to, we can take it as 1 by 2 into sigma x plus sigma y minus of 1 by 2 into sigma minus sigma y cos 2 theta now. Okay, according to the Mohr circle, just it is equal to the values of we taken OQ now, which is equal to here 1 by 2 sigma x plus sigma y is equal to 200 plus 100 by 2 plus 1 by 2 into sigma x minus sigma y cos into 2 into 30 degrees. From this relation we got now, it is equal to here minus sign, please. 150 minus 50 into 0.5, it is equal to 125 megapascal. Shear stress is equal to, according to the circle, it is equal to PQ. Just measure the values. Just according to the scale, you can directly you will get the values now. Otherwise, by using the relationship tau is equal to 1 by 2 into sigma x minus sigma y into sin 2 theta. From this relations 1 by 2 into sigma x is equal to 200 minus 100 into sin theta is equal to 30, 2 into 30, which is equal to 50 into sin 60, or 50 into sin 60 is equal to 0.866, which is equal to 43.3 megapascal now. So if you measure that PQ is nothing but it is also equal to 43.3 according to the scale which is selected now. The resultant stress is given by here OP. It is also equal to the sigma n whole square plus 2 whole square now, or under root of 125 whole square plus 43.3 whole square, 132.3 megapascal. If you measure this to OP, and when you are converting by using the scales, you will get the values of 132.3. That means the analytical method as well as the graphical methods are giving the same values now. The Mohr circles for the stresses on oblique section of a body subjected to direct stresses in one plane accompanied by simple shear stresses. Here consider a body again now having uniform cross section and having thickness is equal to uniform as shown in figure. It is subjected to a direct stress in one plane, that is the sigma x in one plane, and it is accompanied by shear stress to xy as shown in figure now. So from this is nothing but here the forces, the stresses which are acting on oblique plane now, that is ABC as shown in figure now. That is the oblique plane, or it is also called wedge shaped plane ABC. Here construction of Mohr circle now. The first step is as usual with a suitable point, just draw on horizontal lines which is represented area axis as shown in figure, and represent a point O on it at your convenient point now. O point, that is nothing but first of all draw the horizontal lines and represent a point O on it at your convenient position now. Now cut off OJ here now, O and J now, these 2 points here now, OJ, such that it is representing the tensile strength sigma x. Since it is a positive, hence you have to draw the lines from O toward the right side up to J, such that OJ is representing the tensile stress according to the some suitable scale now. Now erect a perpendicular at J and D now. At J, that is here at this point now, J up to D point, such that JD is representing the tangential stress which is acting on the plane now, according to the some suitable scale now. That is now erect a perpendicular at JD above the lines x-axis, that is 2xy, which is a positive because it is now tends to rotate the body in clockwise directions, equal to the shear stress 2xy to the according to the some suitable scale now. That is what is the scale we selected for drawing normal stress. We have to select the same scale to represent the shear also now. That is the D now. Now take C as center. Radius is equal to CD. Radius is equal to here CD. Draw a circle now, or describe a circle. This circle is known as a Mohr circle for the stresses now. Now throw C now. Draw line CP. Throw line here now. Now throw line C here now. Now join here D and C now, and extend this line further to meet the circle at a point E now. Now from C, draw a line which is making an angle of 2 theta, with respect to the CE, to meet the circumference of the circle at a point P as shown in figure now. Here, first of all, what we have taken now? Horizontal lines were taken, and it represented OJ as the sigma x. From J, erected a line D such that it is representing the shear stress according to suitable scale. Now join D and C and extend it further now. Take C as center, radius equal to CD, draw a circle. Join D and C now, and C and E. Join from C, draw a line CP, which is making an angle of 2 theta with respect to the CD, ED as shown in figure now. Now through P now, draw a line PQ, perpendicular OX, join OP. Here from P, draw a line OQ, join OP now. Now according to the Mohr circle now, the OQ is representing the shear stress acting on the plane now. OQ is the normal stress, QP is representing the shear stress, and OP is representing the resultant of normal as well as the shear stresses according to the some suitable scale now. Just to prove now, here, now the radius of the circle is equal to, according to this problem, it is equal to EC, or it is also equal to CD, which is equal to here sigma by 2, because OC is nothing but equal to OJ is nothing but representing the sigma by 2 whole square, plus DJ is representing 2xy whole square under root now. That nothing but is equal to radius of the circle R is equal to. Now in right angle triangle, D, C and J now, when you are taking all these things now, on the cycle, now sin alpha is equal to DJ divided by here CD, sin alpha is equal to DJ divided by CD. From this relationship it is equal to DJ is equal to the shear stress acting 2xy, CD is representing R. Similarly, cos alpha is equal to here CJ divided by CD, or GC divided by CD, which is equal to sigma x divided by 2R now. Sigma x by 2 into by R now. Now in right angle triangle CPQ, in right angle triangle CPQ now, C, P and Q, if you take this triangle now, CQ is equal to, we can take it as CP into cos 2 theta minus alpha, because this is nothing but alpha means the remaining angle is equal to 2 theta minus alpha, which is equal to R into, that CP is equal to radius of the circle, R into cos 2 theta minus alpha now. So, and expanding these equations, we got R into cos alpha cos 2 theta plus sin alpha sin 2 theta now. R it is equal to R cos alpha into cos 2 theta, cos alpha cos theta plus R into sin alpha sin 2 theta now. Here R into cos alpha is equal to, already we determine this values, which is equal to sigma x by 2R into cos 2 theta plus R into, here sin alpha is equal to 2x by R into sin 2 theta now. Here sigma x by 2 is the common word we have taken now, and which is equal to cos 2 theta plus 2xy sin 2 theta now. The normal stresses across the section AB is equal to sigma n is equal to, here normal stresses, which is equal to, here according to the problems, here OQ. OQ is equal to, we can take it as OC minus CQ, which is equal to, OC is equal to half of the normal stress sigma x by 2 minus of sigma x by 2 into cos 2 theta plus 2xy sin 2 theta. Already we determined these values now. The shear stress is equal to, here now, 2 is equal to QP, CP sin 2 theta minus alpha. Here CP is equal to radius is equal to radius of the circle, sin 2 theta minus alpha, and expanding these values we got to R into cos alpha sin 2 theta minus sin alpha cos 2 theta now. From these relations we got R into cos alpha sin 2 theta minus R into sin alpha cos 2 theta. Here R is equal to, we can take it as now, sigma x divided by 2R into sin theta minus R into 2x by R into cos 2 theta now. So the remaining values is Cx by 2 into sin 2 theta minus of 2x cos 2 theta. These are the values already we got it now by using analytical method. That means analytical method as well as the graphical method, when comparing graphical method is the easy method, but just we have to draw the figure neatly according to some suitable scale now. Okay, these informations just are collected from the following textbooks as well as the reference books and web references as well as the e-textbooks. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.